In our previous video, we looked at 3 probability rules. One of them was really the only one that we needed to know, which is that the probability of 2 independent events both occurring is the probability of one times the probability of the other. If there were 3 events, we could repeat that process and multiply all those probabilities together. The other one was the probability of the union of 2 events, which is just one, just the other, or both. And then the probability of at least one thing occurring, which we did a couple of different ways. Let's take a look at one more example where in this problem, we're actually going to have 3 different events. So imagine a study is conducted on daily satisfaction, pet ownership, and daily exercise. Participants in the study were asked whether or not they own a pet, whether or not they are regularly satisfied with how things are going in their lives, and whether or not they exercise each day. Of the participants, 47% stated they own a pet, 82% stated they are satisfied with how things are going in their lives, and 35% stated they exercise each day. Construct a tree diagram as we learned to do in this lesson on probability. The branches list the probabilities for each of the possible types of people. So we're going to have a number of groups here because we have pet ownership. You own a pet, you don't. Daily satisfaction, you are, you aren't. Daily exercise, you do, you don't. So we are going to have a tree diagram, if you can imagine this, that will have 3 sets of rungs. And let's go ahead and build it. And then we'll be able to answer some questions with this. So in our tree diagram, again, let's imagine that what we have is a bunch of people lined up, and we're going to give them instructions on where to move. ... Have a bunch of people here, doesn't matter how many, just think of it as 100% of the people that we have. So we'll tell them, hey, step on board, and hey, if you are, well, since the order is given as pet ownership, this doesn't have to be in this order, but let's just say pet, you do own a pet, will represent with O. Daily satisfaction, maybe we'll represent that with S. So if you aren't satisfied, we'll put a bar over it. Similarly, if you don't own a pet, we'll put a bar over that. And daily exercise. So maybe if you do exercise daily, we'll say you are in group E. So the probability that you are of these 100% of people will say, hey, if you own a pet, move to the top. If you don't own a pet, move down to the bottom. So we know that 47% of people own a pet. So that means that 47% or 0.47 of this 1.00 would move up. And then the 0.53 would end up down here in a separate area. So we're just separating people into own a pet, don't own a pet. Furthermore, now we'll just say to each of these 2 groups, if you experience daily satisfaction in your life, move to the top. If you don't, move to the bottom. And we'll do the same thing here. Of the people who don't own a pet, if you are satisfied each day, move to the top. If you're not satisfied, have daily satisfaction in your life, move to the bottom. Okay. Now, what we are going to assume here is we're going to assume O, S, and E are independent events. In other words, whether or not you're satisfied in life is probably going to be pretty independent of whether or not you own a pet. I'm not saying that it can't contribute, and we could, I guess, argue both ways, but we're just going to assume, because of these percentages, this is all we have, that of the people who own pets, still 82% of them are going to be satisfied with how things are going in their lives. That means that 18% of them are not. Once again, notice that down here at this first rung, the people who move to the top and bottom add up to the 1.00. No weird alien abductions, nothing like that. We're accounting for all the people. 0.82 plus 0.18, again, that's all of the people coming from the O group. And down here, 0.82 of the 0.53 move to the top, 0.18 of the 0.53 move to the bottom. Now, in the previous problem, we only had 2 branches, but because we had 2 events, but now we also have daily exercise. So of these people, some of them will move to the top. We'll say, hey, in each of those 4 groups, let's take whether or not you exercise, and if you exercise, move further to the top. If you don't, move to the bottom. And now, well, what percentage exercise? That's going to be 35%, meaning 65% do not. Again, we're assuming independence. Whether or not we agree with that is a different story, but it's going to make our calculations simple to do. Again, other people who aren't satisfied and who own a pet, hey, if you exercise daily, move to the top. If you don't exercise, 65%, move to the bottom. Of the people who do not own a pet and are satisfied, if you exercise, move to the top. If you don't exercise, move to the bottom. And notice how this all flows like a story. And again, notice that every single split, when you add up the splits in any one group, they add up to 1.00. It's not the 1.00 here. This 0.35 plus 0.65 represents 100% of all the people who have traveled exclusively up. Own a pet, are satisfied. That's 82% of 47% of people. It's not the whole, because not all the people move to the top. Again, down here we'll do the same thing. And because we want to gather joint probabilities, we can multiply along the chain to figure out the percentage of people who do any one of these things. So the percentage of people who own a pet and are satisfied and exercise each day is going to be the probability of one times the probability of the other times the probability of the third. And all we're doing here is we're taking 35% of 82% of 47% of people, right? Because we keep splitting the groups up, so those percentages are going to get smaller and smaller. Those guys do all 3 of those things. They own a pet, they are satisfied each day, and they exercise. So let's multiply these together. 0.47 times 0.82 times 0.35 comes out to, we'll just go to 3 decimal places here, 0.135, just so nothing weird happens. And now we can do the same thing here. I'm not going to write all of these out, but we could say O intersect S intersect E bar. Let me just write this last one out. And that's still going to be 0.47 times 0.82 times 0.65. You could also backtrack to try to get back to where all the people started, and then you could grab all of the percentages and multiply them together. The order of them doesn't really matter since they all just get multiplied together anyway. Okay, that is going to be, just change the 0.35 to a 0.65, comes out to 0.251. So 13.5% of all of these people own a pet and are satisfied and exercise. 25.1% of all of these people own a pet, are satisfied daily, and do not exercise. They have all 3 characteristics. So we'll just kind of repeat this. 0.47 times 0.18 times 0.35. I'm not going to write down all of these probabilities just to avoid making this kind of messy. So 0.47 times 0.18 times 0.35 comes out to 0.030. And let me just go ahead and take a moment to write the rest of these down. So here we have the remainder of these probabilities, and as you can see, I have just multiplied back down the chain. So 0.35 times 0.18 times 0.47, that's going to give us this 0.030. And similarly for all the branches. It might be easier to follow it, like I said, backwards to figure out what to multiply together. Okay, and we should have a total of 8, because notice that we have 2 possibilities at the first rung, each paired with 2 possibilities at the second, each paired with 2 at the third. 2 times 2 times 2, we should have 8 outcomes. And the way we should always check to make sure we didn't make a mistake is that these sum to 1. Now I have verified that these do sum to 1. And what that means is that all 100% of our people have ended up at one of those 8 branches. And so now we can answer questions. Just as an example, if we wanted to know the probability that somebody doesn't own a pet, is not satisfied on a daily basis, and does not exercise, then we can see that that's 6.2% of people, or a 6.2% chance that we would randomly select such a person. So now again, we can answer questions about this that maybe would be difficult otherwise if we just had to figure out what kind of formula to use. So what is the probability that someone does not exercise and does not own a pet but is regularly satisfied? So let me construct this in terms of O, S, and E. So does not own a pet, so that's O complement, and is regularly satisfied, so S, and does not exercise, which is E complement. So we want to know what percentage of people qualify as that, so we'll follow the chain. So that would be people who would walk down, and then they would walk up to S, and then they would walk down to E complement, and so that's going to be 28.2% of people. So we could have just multiplied those probabilities together to get that, but here we have a comprehensive picture of every person. We can answer virtually any question about them that we would like. What is the probability that someone is not regularly satisfied and does own a pet regardless of whether or not they exercise? So what we're asking for here is, what's the probability that they own a pet and are not regularly satisfied? Okay, now whether or not they exercise, well, if we just look at these people who qualify under these 2 conditions, so let's follow that chain. That's going to be O, S complement, and then whether or not they exercise, that's both of these two groups here. Let me pick a different color. So that's these people who exercise and these people who don't. They both have the characteristic of owning a pet and not being satisfied. So we could add those 2 corresponding probabilities together, which are 0.030 plus 0.055. .085. Now another way you could think about this is what we added together here is the percentage of people who own a pet and are not satisfied and do exercise, plus the percentage of people who own a pet and are not satisfied and do not exercise, right? So that's all the people who qualify as both owning a pet and not being satisfied. So when we have 3 events, but we only care about 2 of them, we have to consider adding in both of the third because we're not concerned with whether or not they own a pet. 0.085 or 8.5% of people have these 2 characteristics. What is the probability that someone owns a pet and exercises regularly? So that's the probability that somebody owns a pet and exercises regularly. Well, that again is very similar to up here. We didn't say anything about whether or not they're satisfied. So there are pet owners who exercise, who are satisfied. There are also pet owners who exercise and are not satisfied. Notice that I'm just filling in the blank. This constitutes all people who do both of these things. Let me should pick a different color here. Let's go with lime green. So I can add these 2 percentages together, or really I just have to focus on O and then E. Okay, so we have whether or not they're satisfied, we just want O and E. So that's these people, they're pet owners and exercise. And then we have pet owners and exercise here as well. So adding those 2 percentages together, that's going to be 0.135 plus 0.030, which gives us 0.165. So 16.5% of people own pets and exercise regularly. We didn't, like I said, really need this kind of notation here, but I just want to emphasize that this is where formulas come from. Oftentimes we can derive them intuitively. All right, we can keep on going. Now, the reason I mentioned in the previous video with only our two events that formulas are not always the best and useful thing, because, for example, what's the probability that someone exercises regularly or is regularly satisfied? So what we're looking for here, keyword or, you have to be in one group or the other. So probability that you exercise or are satisfied. Now remember, that's the percentage of people who are just one. So exercise but are not necessarily satisfied. Who do the other? So they don't exercise but they are satisfied. Or the third, where they are both of those things. Remember, or means just one, just the other, both. So we're going to add these three together. Again, you can't be in, there's no overlap among these three groups because, well, you can't exercise and not exercise and be satisfied and not be satisfied. These are three distinct groups of people. So we could further break these up, right? Just like we did in these last two, C and D, we can break up people who exercise and are not satisfied. Remember, we said nothing about pet ownership, so some of these people who exercise and aren't satisfied do own pets. And then there are also those who don't own pets, but satisfy the condition of exercising and not being satisfied. So as we find these two percentages, let's find them first. O and E and not S. O and not S and E, I'll write it that way. So that's going to be 0.030. I probably should have written the S first, but that's okay. So this will be 0.030. That's the same thing as we have up here. We just wrote them I wrote them in a different order. And then the percentage of people who don't own a pet and are not satisfied and do exercise are not pet owners. What did we say? Are not satisfied. So not O, not S. Do exercise, that's 0.033. 0.033. Great, okay. Now, we're going to break this group up, the people who don't exercise and are satisfied. Some of them are pet owners. So owners and S and not E. I'm going to write it that way now so it's easier to find in our tree diagram. Then there are people who don't exercise, are satisfied, but are not pet owners. Okay, and let's grab those from the table. So O and S and E complement. O and S and E complement. That's this 0.251. Plus O complement, or not O, S, E complement. Not O, S, E complement, 0.282. Now remember, we're going to add all these together. There's going to be 6 probabilities, as you might imagine, because down here, now some of these do own pets, but they are satisfied and do exercise, plus the people who aren't pet owners and are satisfied and do exercise. Okay, so all three, they do all three, that's going to be the 0.135 plus don't exercise or don't own a pet and are satisfied and exercise. That is 0.152. Yes, that's what I said. Okay. You can see there's a lot of information that keeps scrolling up and down. So as we add these 4 things together, and we're going to add this plus this plus this, I'll just say big equals over here, 0.03 plus 0.033 plus 0.251 plus 0.282 plus 0.135 plus 0.152, which is 0.883. Now, again, we didn't need to write out all of this notation. I'm just trying to put emphasis on it. We could have just gone up here and just found the people who are in at least one of those two groups. They exercise or are satisfied, or both. Finally, what is the probability that someone is at least one of the following? At least one. Okay, so we'll do this go with red. A pet owner, regularly satisfied, or exercise each day. So this is actually a union of 3 events. So own a pet, are regularly satisfied, so just a union, or exercise each day. Well, let's just go ahead and grab that from the table, and we will just write it down. So we just want to, they're at least in one of those 3 groups. So let's analyze this. Do these 0.135, are they in at least one? Well, they're in all 3, so yes. O, S, in fact, all of the ones that are in O, notice, satisfy being in at least one of them. They are definitely all pet owners, so we might as well just take those first 4 branches and add them up. Be careful because these don't own pets, but everybody in these 2 rungs here and here have at least one because we know they're in the S group. So that's going to be these 2 as well. Now here, these 2, they don't own a pet, they aren't satisfied, but they do exercise. That's this one. And notice that that's everything but this last one, where they do none of them. So in our previous video, we said that the probability of at least one is 1 minus the probability that they don't do any of those things. So either we could add up all 7 of these, or we could just, once again, think about that. I gave an analogy of a stack of paper, of white computer printer paper, that has some pink sheets inserted in there, and it would just be easier rather than taking all the white pages and putting them in a separate pile, and then once we get to a pink, put it in a separate pile. Just reach in there and grab the ones, pull the ones out that we don't want. So I'm just going to write this as 1 minus 0.062. Could we have done that from the beginning? Yes, but I wanted to place the emphasis on you could just find what you want in the tree diagram and put those all together. So we could do this with 4 events or 5 events. Of course, the tree diagram would quickly expand and grow, but this is at least one with 3 distinct events.